So welcome back. So in the previous lecture we discussed mostly about the different definitions and of paleoseismology and allied fields, and the importance of the paleoseismology, and also we talked about that the onset of this field, like when it started way back in 80s, and after that we have also started like in India this part, and the importance of the paleoseismology. Now moving further, as I was talking about, that this field requires the knowledge of different allied fields. So for example, the paleoseismology itself is an interdisciplinary field which requires the knowledge of structural geology, geomorphology, sedimentology, photogrammetry, soil sciences, petrology, and dating part. So in short, if we talk about, we are covering almost all allied fields of earth sciences or geology to understand the earthquake process. So the structural geology part, you need to know on the global, regional, and local scale, and the landforms which have been formed by tectonic activity, and this will be we will be able to achieve this aspect using photogrammetry or satellite data interpretation. And then the sedimentology part is important because we are going to look into the sediments also. So signature preserved in sediment succession, and we also should know about the soil types, because this will also help us in interpreting the change in the environmental conditions because of the tectonic movement. And finally the dating part, where we will be mostly dealing with the OSL and carbon 14 dating, which helps us in bracketing the events or reconstructing the earthquake history on an individual fault. So before we will move to the details of the paleoseismology, field techniques, and all that, we will also try to cover some basic parts which are fundamental parts, and the plate tectonic we will discuss later on after in this lecture, but straight away we will go to the part which is required for the initial understanding before we get into the details. Okay. So plate tectonics we will try to discuss later on. Coming to the structural geology part, the deformation through forces and stresses. So under different stress pattern, you will have different pattern of deformation. Okay. And mostly if we are talking about the deformation on the surface, then we are talking about the differential stress. And deformation, basically the structural geology can talk about the deformation due to uniform or differential pressure or differential stress. So for example, if you have that what we call the thumb rule, that all deposits were horizontally deposited, or the sediments were deposited horizontally, and but due to the differential stress, we see the deformation and then development of the topography. So lithostatic stresses sigma 1, sigma 2, sigma 3, equal pressures on all the sides, usually the case within the earth. Okay. And further differential stress, whereas are not the same. Sigma 1, sigma 2 and sigma 3 are different. They are not same, where sigma 1 is the maximum, sigma 2 is intermediate and sigma 3 is minimum. So mostly the deformation which we see on the surface is because of the differential stress pattern. So differential stresses are associated with tectonic activity, and whatever we are talking about the paleoseismology, we are going to deal with the tectonic activities. So rocks or sediments usually occur in form of layers covering a large area, and this is because we are going to look at younger deposits. So for us, the younger sediments and the landforms are going to be an extremely useful portion. So the layers or the beds may be horizontal or inclined, okay, but due to deformation or the tectonic activity, and as I was saying, the differential stress, okay, the layers which were deposited horizontally or slightly inclined, or so this rock layers or the sediment layers under the influence of the tectonic forces exhibits complex structure. That is, what you will see is either they are bent, warped or folded, or finally what we see is the fracture and further displacement along a definite plane. So these features are known as the structural features. So for us, the part of the structural geology, we will be interested in knowing that what type of deformation, either they are folded, we are just looking at the inclined beds, or they are just warped, or they are showing some displacement. So any fracture which is showing the displacement will be termed as faults. Okay. So these are all the basic structural features which we should know. Okay. So further and details, if we get into the structural geology part, the fundamental structures you can have in a broader sense, you can have in three subcategories. One is your primary structures, secondary structures and contact structures. Because to differentiate between the tectonic and non-tectonic origin of the structure will be important for us, because you should not misunderstand the non-tectonic features. For example, the contact structures could also mimic that they are formed because of the tectonic activity, and of course we also should know about the primary structures. Okay. So for example, we are having horizontal beds or the layers of the sediments, and so these are the primary structures, and if you are having under the deformation, then you will see the folded ones, they are the secondary structures. So the primary structures, if you take, then we have mostly the sedimentary structures we take into consideration. So the primary structures are those structures which are developed during the phase of formation of rocks or during the phase of deposition of the sediments. So what you see is the sedimentary structures, these are all primary structures or primary contacts. Bedding in sedimentary rocks, gneissic bends in metamorphic rocks are termed as the primary structures. Even the mud cracks, okay, are the primary structures. Now this is one of the best example which most of us will come across in terms of the sedimentary structures, and can do mistakes in identifying or differentiating between the tectonic and non-tectonic structures. So most of the time what we say that the geologist should try to look at the wider areas, okay, instead of looking at the smaller portions of the exposed sections. Okay. Now, what we see here is that we have, carefully if you see on the left hand side, you have horizontally stratified sequence, and then you have one boundary here which goes right up to this here and then dies out. So, this trough feature is nothing but the channel, river channel. Okay. So, this is an old river channel which has incised this deposits. Okay. So, you are having horizontal layers here, and this contact is an erosive contact. Now, for example, and in this also the picture is not very clear, but you can make out to some extent. You have some structures here, you have something over here. Okay. So, these are all primary sedimentary structures. Now, what mistakes, or without looking at the regional scale, one can come across or can do the mistakes is that if suppose you look at this portion only. So, I will just remove the rest of the part here, and then so we know that this is channel because we are able to see the whole area. But suppose you are looking at this portion only, okay, the smaller area, this one only. Now, if you want to sketch this, then what you will see is, because usually the faults which that in detail I will talk later on, but suppose you are having horizontal layers like this, and if they are faulted along this fault, for example, then what you will see is there is a displacement along this, and you have this layers. So, there is an abrupt termination somewhere along this line. Okay. So, this is your fault plane. So, this becomes your secondary structure. So, you have the sediments here, which have been displaced. Okay. And now, if you sketch this portion, then what you are able to see, I will just sketch in a smaller one here. Then if you, so you have these layers here, and then there is in contact which goes like that. Okay. And then you have this thing here, and then some layers are seen over here like this. Okay. So, again, if you compare this with this one, it is more or less similar. It's more or less similar. Okay. So, you have what we call is the unconformity, or you can say that the cross-cutting relationship between the layers are distinctly marked along this line, and here also you can see that they are distinctly marked between this line which has been marked here. Okay. So, if you are just looking at this and then you are talking about something that whether it is a sedimentary feature or not, you may say that this is related to tectonics, because in faulting, because this is under the compression, the portion will break and it will move up, and it will give very similar feature. But if you look at on the regional scale, okay, and if you look this whole in one shot, okay, then you will be able to trace this channel here, and then you can say that this is the earlier deposited sediments which were been cut by the river channel. or we because this is hanging along the cliff, and so we also term this as an paleochannel. So basically this is your sedimentary feature. So differentiating between the primary, this will be sedimentary feature of course, but this will be what we call the primary structure, and this becomes the secondary one. So you can mimic easily between the tectonic and non-tectonic. So it is always better to look at on the larger scale and cover more area to understand, and like you can at least come to the conclusion that whether this is tectonic or non-tectonic. Further example, this we did in Kutch, where so Kutch is one of the other most active areas in the Indian subcontinent, and has like produced or experienced many large magnitude earthquakes. So this exercise we were doing in mapping the active fault, and the elevated portion what you see here is the active fault scarp along Kutch Mainland fault. So if I just put the cross section across this, for example, then how it looks like is something like this. Okay, it goes like that. So with the topography and with the experience, what we say that okay, fine, the fault is sitting somewhere here. So in the plain areas. Okay, so we have moved in the plain area and we dug the trench to see the section. So what was expected is that there is a deformation here. So we will find something displaced sediments over here, and we'll be able. So we dug the trench like this. Okay, so this is the trench which has been shown here. Okay. But we'll see in the coming slides that what mistakes one can do if we are not trying to understand the overall contexts as well as the features. Okay, so differentiating between primary and secondary feature becomes extremely important. So trench 3, if you look at, this is what we dug. The trench is almost like 1.5 meter deep, and this portion was the area of attraction in the sense, because somewhere over here, I will show the close up, we were able to see the contact, okay, which could be a tectonic contact or a fault here. So this is the close up here. Now again, as I traced the lines, that is the sedimentary structures, and one can easily make out the sedimentary structures like this over here, and goes like this. It ends somewhere along this one, abuts along this line. Okay. So this is the line here. I'll remove so that you will be able to see, okay, which goes right up to this, and then further on this side also, on the right side of this line, we see some prominent sedimentary structures. So we could have easily said that this is a fault here, okay, and this is your the faulted block, and this is the stationary block here. But what you are not able to see here, as I have been drawing this sketch, okay, the previous sketch if you take here, okay, what I was showing here is that you will able to see some deformation along this line, okay. So and that we were unable to pick up here So we didn't see any deformation on this part. If we have to interpret, like if you say that this is a deformation, then we must have seen something like this, okay. But we did not see that. We are still having a very straight and prominent layers which are sitting. So this is nothing but a channel fill deposit, similar to what we were looking at, that you are having this layers here and this some channel has cut. Okay. So we are again looking at a very small portion over here. So this is not a tectonic feature. This is in a part of primary structure. Few more slides. So what we did was that we were not satisfied with the features which we identified here. We opened up another trench, and which was the trench 1, okay, and we definitely were satisfied that what we were looking at in this trench, trench 3, we were looking at primary structure, and in trench 1 we were able to see the secondary one. So this is the close up of that, and the displacement of the layers can be seen clearly along this line. So this layer is sitting somewhere here, and there is a clear cut displacement. And then what I was talking about, that you will be able to see some sort of an warping, okay, or the folding along the plane, and that we were able to pick up here. Okay. This is the close up of that. So you can easily make out the displacement. Now I'll just put the cursor here. You can see this line along this sharp line. This is your fault plane, and you are having this layer is sitting here, which is displaced along this one. So there is a fault here which has moved and brought this sediments on top of this one. Okay. So you have, like, if I just put the boundary here of this one, it goes something like this. Okay. And this layer is sitting over here. Okay, there is another line here, which is, so only this unit, if I put, okay, then this is something here, and then you have this fault which goes here. So there is a clear cut displacement along this, as well as what we see is the warping. So what we see here is the folding, displaced sediment layers along a fault plane, and based on this, okay, we straight away we can say that this is your secondary feature. So the differentiation between the primary and the secondary feature or the structure is going to be an important part in this course. Okay. So here the knowledge of sedimentology is extremely important, because you cannot do mistakes in identifying the primary, and or you should not do mistakes in differentiating between the tectonic and non-tectonic feature. This is the most important one. So I'm removing all this so that you can easily make out what I was talking about in terms of the deformational features. So few more slides I'll show on this so that you are aware, and of course we will keep on discussing when we are talking about the trenching part. Okay. So this is what we have done, the trenches and the squares which you see here, the grids, okay, because we need to map each and every layer. This we will talk in detail when we are talking about the field techniques and all that. So we have almost 3 faults here. One is here, another one is here, and third one is here. Okay. So close up of one of this, okay, if you see, then This is in black and white, which also enhance, and you can play with the colors and try to identify the features. So you can see this deformation along this one, then it's very sharp line here along which the deformation is there, and there is third one which goes here. Close up of that. Now I hope it is more clear to you. So you have the line here, and the beautiful part, if you see here, is this layer. Okay, this layer goes here and then get into this and then fold it. Okay, and this one also is getting folded over here. So this layer is sitting here, and this again is over here. So along this one this is faulted, along this one it is faulted. And in terms of the primary one, what we were able to see was something like this. Okay, so there was no deformation, but here we see, so the contact is more or less similar. This contact is more or less similar to what we see here, but yes, of course, it is not so curved what was been observed in the primary structures. Okay. Another close-up of the fault which was been seen towards the south, that is in this portion here. A close-up of that. Okay. You can see the folding on this one, and the fault goes like this here. So these are few, of course, the basic things which we should keep in mind when we are moving into the field. Either it is in terms of the landforms, because there are many landforms which will mimic that they are probably the product of tectonic activity, but they might not be. They might be simply erosional features. Okay. So we'll talk more in detail in the next lecture. Thank you so much.